Brad Guy, and I would like to welcome you to the Catholic University School of Architecture and Planning this morning. I'm an assistant professor here in the Master of Science in Sustainable Design program and teach the core Sustainable Materials course for the program. I've also been fortunate to be on the lead Material and Resources Technical Advisory Group for the last 4 years, during the period over which lead version 4 was developed. As Brendan Owens and others at USGBC might tell you, there's been a high level of change in this particular category. And we all know how important LEED is in driving the market for green building. There's also been a very high level of engagement in that process, and we're very fortunate that USGBC is continuing that engagement now that LEED v4 has been rolled out, especially in this aspect of materials health. I want to thank Chris Pike and USGBC for engaging with Catholic School of Architecture to host this discussion on the architect's role and architectural education in addressing the health of materials used in the built environment. I propose we have two considerations. What and how is a standard of care to be defined for the architecture engineering community for the selection of the stuff that the built environment is made from? And secondly, how does architectural education and practice answer this need in light of what has been traditionally the realm of chemists, toxicologists, industrial hygienists, environmental engineers, and so on? This may be in the traditional role as the maestro of the orchestra, which is a well-defined role for the architectural profession. However, the materiality of a design is more than the sum of its parts. And the one realm, I think, that in fact the architect has to bring to bear is both the quantifiable and the quality of design, which is the basis of the discipline. And it is in fact the architect's role to act wisely in all of those realms. There's a long history of reactive and so-called end-of-pipe efforts around mitigation or cure for problems, waste, pollution. Now we see climate change. Perhaps we can consider the 21st century to be the opportunity for a wiser path of restoration and preventative architecture realized through the professionals that we're training today. So again, I want to thank you for taking the time on your busy Monday for coming to this symposium. And I just want to give you a few logistical notes. During the lunch break, you'll notice right outside the auditorium and in the main space where you came to the registration table, students will be setting up their 4th year comprehensive building design studio for reviews this afternoon. So I want to encourage you or ask you to feel free to take a look and see what the students are producing. And also bathrooms. So they're right on the sides, behind the screen, on the corridor that's on either side of the auditorium. The men's is over here on your right, and the women's is over here on your left. So I hope you'll have an educational and enjoyable morning. And I think we're going to have some words from Chris Pike, Vice President of Research for U.S. Green Building Council. So thanks again.
All right, good morning. So I want to echo Brad's welcome to you guys, and thanks everyone for coming out. I wanted to give a few thoughts from the USGBC perspective. First off, we are very thankful for the program and for Catholic for hosting this event here. This is just the kind of forum that we have wanted to create. And so the background for this event is that, as Brad mentioned, there has been a lot of focus on expanding our understanding of the role of materials in the built environment over the last couple of years. That has come with a degree of an increasing awareness of the implications, particularly for health and well-being, of materials selection. At the same time, it's come with a degree of controversy. And part of the issue, we've had some generous support from Google, which has had a progressive mindset toward encouraging the selection of inherently safer and less toxic chemicals. But part of this has come with the burden of basically saying, what is What are the scientific, technical, and intellectual foundations of this argument? And so one of our goals today is to have a conversation that is both focused on what are changing expectations for architects and design professionals, and at the same time, what are some of the underlying scientific and technical issues that are coming to bear? Because, as Brad said, these are often outside the scope of traditional architectural education. We are talking about issues of toxicology, material science, chemistry, green chemistry. We're talking about physical properties as well as public health. And the gamut of things that are being brought to bear here is unusual, and it's very challenging. And so when we think about how USGBC is thinking about these issues and how we are reflecting and striving for an evolution in green building practice and in LEED more specifically, I'll also call out Joel Todd, who's here she's the past chair of the LEED steering committee, and she has the privilege of having and the responsibility of having brought to bear most of what we call LEED version 4. And in LEED version 4 is part of an evolution of thinking in green building where, and just to give you just a brief comment on it, what we envision is that we are moving through a process where we're promoting transparency about materials attributes. We're encouraging assessment of hazards, and ultimately we're trying to encourage design teams to optimize their decision making, to make hard trade-offs in materials, to come to situationally appropriate choices. And each one of those terms, transparency, assessment, optimization, as both a progression and a thing unto itself, is something we're going to be talking about today. So I appreciate everybody who's been involved with that. So the privilege I have is to give is to stop talking first, and second, to introduce a trio of basically technical speakers who are going to help us lay the foundations for this work. And so in just a moment, Dr. Tracy Wilmanson from the U.S. Environmental Protection Agency is going to come up here and talk about some of her work. She specializes on issues of new and existing chemicals in the environment and green chemicals for US EPA. She's got 20 years of experience, so she's got lots of things to share with us. And we're also then going to hear from Larry Kilroy, and Larry is at the forefront of the tools that architects and other professionals need to make informed decisions. And then Dr. Ashley White is our senior research fellow with our program, and she's going to talk about materials science and the process of materials innovation, hopefully to give us a sense of the pace and challenges associated with bringing new materials to market. So with that, I will get out of the way, and I'm looking forward to a great discussion this morning, and appreciate you guys being here. Tracy, please come up and join us.
Good morning. I could probably spend hours talking about some of the topics that I was asked to present to you here today, but I have about 10 or 15 minutes, which isn't a lot of time. So I'm going to give you an overview of just a couple of key programs that have relevance to the building and architecture sectors. First, I want to thank the hosts for this opportunity. This really is a great opportunity to be here today to talk to you about some of the work that we do at EPA. Basically, there's a number of programs across EPA that are relevant to buildings and architecture. I'm going to talk about just two program areas within the office that I am in, and that's the Office of Chemical Safety and Pollution Prevention. Basically, this office is responsible for developing the national programs, policies, and regulations to protect the public and the environment from exposure to chemicals. And those are both pesticides as well as industrial chemicals, as well as chemicals that might show up in consumer products. There are three primary statutes that our office is responsible for overseeing, and they are the Federal Insecticide, Fungicide, and Rodenticide Act, the Toxic Substances Control Act, and the Pollution Prevention Act. So today I'm not going to talk about the pesticides work, but there obviously is key relevance to the topic today that we're all here for regarding the Toxic Substances Control Act and the Pollution Prevention Act. Okay, first, I'm going to spend just a few minutes talking about Toxic Substance Control Act, or TSCA. TSCA was enacted in 1976. It basically establishes a national chemical reporting and management program. Unlike other statutes at EPA and elsewhere that can delegate authorization to the states, TSCA does not allow that to happen, so it does not provide for state programs. So TSCA is basically administrated by EPA out of headquarters in Washington, D.C. TSCA has 31 sections, so it's a very large and comprehensive law. It does give EPA fairly broad authority to review and regulate chemical substances. There's several core provisions, and they include Section 3, which is basically definitions. Section 4 authorizes for testing of chemical substances and mixtures. Section 5 is our new chemicals program. Section 6 provides additional authority to regulate hazardous chemical substances, and these are typically would be existing chemical substances, and I'll get into the distinction of those in a minute. And then Section 8 is important for us. That's the reporting and retention of information. Regarding the scope of TSCA, chemical substances included in TSCA are basically anything that meet the definition of chemical substance in the statute. And there is a pretty good definition of chemical substance. And it basically says it's any organic or inorganic substance of a particular molecular identity, including any combination of such substances occurring in whole or in part as a result of a chemical reaction or occurring in nature. So it's actually not a bad definition for something that's actually in a law. And that does basically provide the scope of what EPA is able to review and regulate under that law. Now, having said that, however, there are some chemicals that are excluded, and some are excluded by statute. Basically, a chemical that is subject to any other law in the United States will not be covered by TSCA. So these include, again, pesticides, which are covered by FIFRA, the other statute that I mentioned. FDA, of course, reviews and regulates foods, drugs, and cosmetics. Nuclear source materials are covered by the Nuclear Regulatory Commission, and so on. So basically, TSCA covers everything else, all of your industrial chemicals, a lot of chemicals that do show up in consumer products. There are some chemicals that are excluded by regulation, and these include naturally occurring substances. Also, there's incidental substances that are not included, and these would be byproducts that don't have a commercial purpose, impurities, and things similar to those materials. Now, I mentioned about a distinction between new and existing chemical substances. When TSCA was enacted in 1976, the first action that EPA took was to compile an initial inventory of industrial chemicals, and this is mandated under Section 8 of TSCA. So at that time, there was a large reporting program. The industry needed to report the chemicals that they had in commerce at that time, whether they be manufactured or imported. So EPA received about 150,000 reports and compiled the initial inventory, which was about 62,000 chemicals that were in commerce at the time. So basically, all of those chemicals that were in commerce when TSCA was enacted were grandfathered on this initial inventory. The next action that EPA took after TSCA was enacted was to establish its new chemical program. So a new chemical is anything that isn't already on the TSCA inventory, so isn't yet in commerce. An existing chemical are those chemicals that are on the inventory and are already in commerce. Section 5 provides authority to EPA to review and regulate new chemicals, and this is prior to being commercial. So industry must provide a notice to EPA on chemicals that they want to put into commerce, whether it be domestic manufacture or import. OPPT, which is a sub-office in the Office of Chemical Safety and Pollution Prevention, then reviews those notices and determines whether there's any need to regulate or somehow restrict those chemicals before they are granted into commerce. So the tools we have available to us for reviewing and regulating are pretty broad. Chemicals can be fully granted in commerce if we find little to no concern. We can ban, and we do ban a number of chemicals through the new chemical program, or there's a number of regulatory actions in between that we might impose upon a manufacturer or importer of those chemicals. So to date, we have reviewed more than 45,000 pre-manufacture notices. We get somewhere between about 1,000 and 1,500 a year. It's been as high as about 3,000 a year. Once a chemical has been reviewed and granted to be able to be in commerce in the U.S., the chemical then gets put on the inventory only after it is commercialized. Not all chemicals that review end up being commercialized by companies, so we only put those that are eventually commercialized by a company on the TSCA inventory. So currently we have about 84,000 chemicals on the TSCA inventory. A little bit on existing chemicals. Once a chemical's on the TSCA inventory, EPA can still review and regulate if additional information is provided to us or discovered by us. However, some of the challenges in implementing this particular law do center around existing chemicals. The burden is higher for EPA to prove hazard or risk. So there's a slight difference in the wording in the law that makes the bar higher for EPA to review and regulate existing chemicals as opposed to new chemicals. So a lot of them are actual legal challenges. There's procedural challenges for us to do that. Some current efforts that we have underway to try to improve upon our existing chemicals programs, to try to overcome some of these obstacles and hurdles that we have facing us are listed here. We're currently very much involved in trying to target priority chemicals. There's a lot of chemicals in commerce in the US and around the world. So we're trying to do a better job targeting priority chemicals to get the information we need to understand the risks and hazards of those chemicals. We also engage in a number of risk management activities, and these can be both regulatory and voluntary. And we're also very much engaged right now in trying to increase public access to information about chemicals. And this can be working with industry to reduce the confidentiality of a lot of the information that they provide to us. We're also working to improve our public tools to make information that we have more available to the public. On this slide is a list of some of the priority chemicals that we're currently reviewing. Some of the chemicals listed under this first bullet are those that we have reviews and are starting some action. So this is work that's underway. They include chemicals like bisphenol A, phthalates, dyes. Brominated diphenyl ethers is a flame retardant, hexabromocyclododecane, the same. Also, diisocyanates are rather ubiquitous in the manufacture of a number of polymers. Short-chain paraffins is something that's been in the news a lot. We had recently concluded a pretty extensive enforcement action against a number of companies that were manufacturing illegally in the US. So these are just some of the chemicals that we have more targeted reviews and are planning some regulatory action. All of those except the paraffins have some relevance to the building and architecture sectors. So again, a lot of these are again, fairly ubiquitous chemicals, and they find their ways into a lot of different products that, again, are used by a number of different industries, but including buildings. Some new reviews that we're starting, we're looking at an additional group of flame retardants. There's a number of different classes of these materials, and they all pose different concerns and risks. So we're starting to expand our look at the flame retardants. Some long-term projects that we've had underway are perfluorinated chemicals. Also, at one time, were ubiquitous. These have been largely phased out. Also, formaldehyde nanomaterials. Of course, there's a lot in the news about nanomaterials. These are finding their way into a lot of applications, including buildings, some very specialized applications. Also, formaldehyde. We've been looking at that for a number of years, especially since Katrina. That was in the news a lot because of the use of formaldehyde in adhesives for building materials, especially composite materials. And so that is something that we've been looking at closely and working to reduce the use and find alternatives. So in terms of alternatives, at this point I do want to switch gears and talk about some of our voluntary programs. Again, there's a lot of different voluntary programs across the EPA that very much complement our regulatory work. Many of these are conservation programs like WaterSense and Energy Star. A number of them are risk management programs like DFE, Design for the Environment, Green Chemistry, Green Engineering. So I really only have time to focus on one, and I will focus on green chemistry because that is one of the activities that very much complements the work we do under the Toxic Substances Control Act. Again, looking for alternatives to those chemicals that are in commerce or that we're working to get out of commerce. Green chemistry is basically design of chemical products and processes that reduce or eliminate the use or generation of hazardous substances. So it's pretty broad in scope, but really looks at all aspects of a chemical life cycle. In terms of the scope, we do tend to look at it in terms of a couple of different focus areas. One is looking at an actual chemical product, so looking very upfront at the design and development of safer chemical products. So again, looking at those to reduce their particular inherent hazard or risk. This also can include making chemicals either more recyclable or having them be biodegradable once their useful lifetime is up. So there's a number of different aspects that we do look at to try to improve on actual chemical products. And again, very much upfront, looking at it at the design stage so that you don't create those downstream problems later on. Another area that we look at very closely is the actual manufacturing and processing of chemical products. You can have a very green chemical product, but it could actually be manufactured in a very ungreen way. So we do look at how chemicals are manufactured and otherwise processed and also used. So we're looking to minimize hazardous chemicals that go into these processes, looking to minimize any waste generation, also looking to minimize energy and water use, and of course maximize yield. Another area that we're looking at more closely, more recently, is supply chains and how you get information, again, across these supply chains that can be fairly extensive and complicated for a number of different sectors. And so it's about getting information from the very early stages all the way downstream so that users, consumers understand the choices that they have available to them. At EPA, our efforts in all of our voluntary programs, but including green chemistry, really center on speeding the adoption of these greener products and processes. So we really want to see greener products in particular be designed and developed, see them manufactured in a more green way, and to get them out in commerce and get them used. We do this through a number of different ways. We do have incentive programs. Our office manages the Presidential Green Chemistry Challenge Awards. This program is an annual, very competitive recognition event. Provides very high-level recognition for winning technologies, but it's also a good way to get the word out about a lot of different technologies that are nominated to the program. So it not only gives credit where credit is due, to these, to sort of the best in green technologies, but it also demonstrates, the benefits that these technologies do offer. They are real commercial options in many cases. One thing we do at EPA, both in the office that I'm in as well as in our Office of Research and Development, is try to stimulate research. So if there is an area that is lacking in alternatives, we do try to provide programs to promote research in that area so that eventually there will be alternatives developed for industry in particular to have those choices. Just quickly, in terms of future emphasis, we are sort of switching gears a little bit with our green chemistry program. We're trying to expand upon our awards. We do get a lot of information in through that program on green technologies, and we're trying to focus on expanding upon those innovations, getting the information out to users in a better way. Also, the America Competes Act, which is recent, does give us authority to focus on market and economic issues. So we are very much interested in trying to amplify innovation by leveraging technology and manufacturing initiatives, and these can be federal, state, and local initiatives. They can also be private sector initiatives. So that's a fairly new area for us. We're also very much interested in working more with partners, working with the innovators on the supply chain opportunities that I already mentioned. A little bit more on the data. I mentioned we do get a lot of data in through our different programs, but especially our awards program. On our website, you can search and sort on all the nominations that we receive for the awards program, for example. And you can search either a number of different ways, either by technology or by sector, for example. This slide shows how you can sort on winning nominations by industry sector. And this shows that we do have a number of technologies that were award winners that are relevant to the building sector. I'm going to just quickly mention a couple examples. The first is development and commercial application of environmentally friendly adhesives for wood composites. This was a partnership project by Professor Lee of Oregon State University, Columbia Forest Products, and Hercules. Basically, they developed an alternative adhesive for plywood and other wood composites, and it's using soy flour. Basically, this avoids and eliminates formaldehyde from those wood composite products that I mentioned previously. In addition to having benefits to human health and environment, these adhesives are also found to be stronger and are very cost competitive with a conventional adhesive. So again, it's a good alternative that actually is commercialized and in the market. The second example is Archer RC. It's a non-volatile reactive coalescent for the reduction of VOCs in latex paint. This was developed by Archer Daniels Midland Company. Basically, ADM developed a bio-based coalescent to replace traditional coalescents in architectural latex paint, which is actually the largest market for this particular kind of paint. So it replaces VOCs, and again, it offers a renewable feedstock, and then it's bio-based. Again, this also, in addition to providing benefits to human health and environment, also provides performance advantages, and that includes lower odor, increased scrub resistance, and better opacity. So again, another good alternative that has been commercialized and is on the market. Final example I'm going to give you is ACQ Preserve, the environmentally advanced wood preservative. This was developed by Chemical Specialties, Inc. It's now Viance. Basically, this company developed an alternative to the chromated copper arsenate wood preservatives that were ubiquitous for a number of decades in wood products, especially wood decking material. Chromium, of course, this is hexavalent chromium that was being used, very toxic, and of course arsenic is also very toxic. This particular company developed a quaternary copper material to be used as a wood preservative. So basically eliminates the use of the chromium as well as the arsenic. So a much improved alternative by eliminating those hazardous materials. This is commercialized, has been for a number of years. It has the potential to eliminate up to 40 million pounds of arsenic and 64 million pounds of hexavalent chromium each year from these wood building products. It's been certified by appropriate organizations in the U.S. for both ground contact and above ground building applications. And with that, I'll say thank you. And two quick messages, takeaway messages, though. You might be thinking, what the heck did she cover really quickly in 10, 15 minutes? Two quick messages. First, the materials and the chemicals that are used in building products are regulated by EPA under the Toxic Substances Control Act. Many of them do have hazard concerns and risk concerns. Second takeaway message, there are alternatives out there. Maybe not as many as we would like, but it's getting better all the time. There are good alternatives on the market. So as practitioners and users, I would encourage you to look into those alternatives, be more knowledgeable about what's available to you. And with that, I'll say thank you.
Good morning. My name is Larry Kilroy. I am the Information Systems Director for the Healthy Building Network. First, I'd like to thank the hosts for today's event. I think this is a great opportunity for all of us. I'm going to try just talking today. I'm not going to use slides. I know it's not the best idea maybe this early on a Monday morning. But while I am competent at building sophisticated web applications and data structures, I have not yet mastered PowerPoint animations. Oh, hey, there we go. As proof in the pudding right there. So now that we've learned a little bit about toxics, green chemistry, and human public health, human health, let's take a look a little bit at where they intersect in the built environment. These are the spaces. When I say built environment, I'm talking about the spaces we live in, we work in, we play in, we heal in. At the Healthy Building Network, this is why we consider our mission to be to make the building materials market healthier for its primary consumers, our colleagues, our children, our teachers, our doctors. We also believe that there's a demand in the industry to be part of this change. So the question really is, where do we start? Now, many of the chemicals in the built environment that we're concerned with are brought into the environment by building materials. So our focus has always been on what is brought in those elements. There's other things to consider, but we've had to pick one focus, and that's the one we chose. And we know most of the chemicals we want to avoid. We know the priority chemicals that we want to avoid. They're on lists. They're on these hazard lists put out by government agencies like the EPA, European Commission, and NGOs like the World Health Organization. In recent years, architects have worked with these NGOs and these government agencies and state agencies to create what are often referred to as red lists. And these are chemicals to avoid when specifying building materials. And on the manufacturer's side, these are chemicals that should be prioritized for optimization and phased out eventually of their products and replaced with greener alternatives, as we were just learning about. While we believe that red lists we need to go beyond the red list approach to really make meaningful impact down the road, we do believe that we need to start someplace, and that red list gives a very good jumping off point to start creating change in our building materials. So you could conclude that since we have this list of chemicals, it would be very easy to start avoiding them in our buildings. All we need to do is know what our building materials are made of. And that is really where the rub is. At Greenbuild in 2009, the Healthy Building Network launched our Pharos Project. It is a research and decision-making tool for the design community. Our concept was that in order to make decisions that better represented the values of the A&D community, which are really starting to trend towards healthier, sorry about that, that you all really needed to know what were in these building materials. And this was our effort to work with manufacturers, to work with architects, to start to bridge that gap, to create that table where we had the conversation of what are these materials made of, what can be optimized, what can be phased out. The newsletter we put out on the day we launched it heralded the coming age of transparency in the building materials market. 5 years later, I think we have a good reason to believe that we are just really entering that age. So we know from building owners and from the A&D community there is a great demand for this information. We know there is a growing desire among manufacturers to provide this information. However, demand and desire are not the only requirements that we need to make our products healthier. We need to make better tools to aid making healthier decisions. We need better tools for manufacturers to use to optimize their products to be healthier. And these tools need data. And we need data all the way down the supply chain. And that, to be honest, is going to take a lot of work. A good illustration of the data challenges we face when searching for chemicals of concern in the built environment are represented in some of the products we've modeled in Pharos. I chose one example we're all familiar with, present in almost every room we wander through, carpeting. We work with most of the major carpet manufacturers to profile their products in order for them to be transparent about what they're made of. One manufacturer in particular's experience, I think, is a very good illustration of what we're dealing with, both as far as the challenges to tools to help all of you make better decisions, but also to the manufacturers to report data out to you. The manufacturer reported that the carpet was made of 5 components: a face fiber, a primary backing, a secondary backing, an adhesive, and a stain repellent. Pretty simple, 5. But all but 2 of those were actually made by other manufacturers. So they didn't actually have the root elements of those components that we would need to look at a hazard list and assess what we were looking at. The way this is often done is with something called a CAS number. I'm not going to go too deep into it, but is a chemical identification system that is common in the industry. Most importantly for us, it's also what is often the primary identifier used in these hazard lists to know what the potential health endpoints of concern are for a chemical. So we had to begin working with this manufacturer to try to get the CAS numbers for the materials that they didn't actually produce at the very kind of raw ingredient basis. So we quickly found out that those 5 carpet components were actually made up of 10 subcomponents manufactured by 5 manufacturers. We helped the manufacturer request the data from those, and we provided a data entry tool to help aid gathering this information, since one of the challenges we face is there at the time was no real common reporting format to address helping pull this information up the supply chain. Challenge number 2. 2 of the companies refused to provide any of the data citing trade secrets. So dead end there. Challenge number 3. 2 of the manufacturers of the subcomponents wanted to provide all the data, but to be honest, they only knew some of it. Some of it they didn't have CAS numbers for some of the chemicals they used. They just bought on the marketplace this chemical, and they were not able to identify it uniquely to that top-level manufacturer for us to use for identification. Only one of the 5 were able to actually give us a very good profile of what was in their building material. And this is common in the supply chain. And in this case, the carpet industry, we only had to go down a couple levels, but when you look at something like furniture, you're going down 10, 12 levels. So that just gives you an idea of what type of challenge is ahead of us. So in the end, with the information that we had and several months of work with this manufacturer, we had only identified 67 chemicals that had a CAS number that we could screen. Only about 70% of the product as far as the product weight itself. And that's using I'm biased, one of the best systems out there to try to go ahead and pull this data into one place and make it easy for a manufacturer. We're still talking about a very significant investment on their part. So the lesson there for us was that demand and desire are not enough. We need better data, and we need to get that better data, we need better systems. We also need a campaign to drive the demand and the desire down the supply chain, because right now it's sitting kind of at the top level. We really need to provide manufacturers the leverage to send the incentive down their supply chain to provide this information. 3 years ago, the Healthy Building Network convened the Health Product Declaration Working Group with Building Green. The working group was made up of architects, designers, building owners, and manufacturers. The idea was to create a common reporting format for product ingredients augmented with chemical hazard list data. The belief was that the common reporting and hazard assessment format would make it easier for the A&D professionals and building owners to request the information. It would also make it easier for manufacturers to respond with data, because they could, right now they respond to multiple requests in multiple formats. The idea that if they could respond with a single set of data, that could be passed around and shared as they wanted, and they would really only be answering these questions once, so it would really lower the burden of participation on the manufacturer going forward. The HBD format was also trying to address one of those challenges I mentioned, which is to get around the trade secret issue and allow manufacturers to identify the chemical hazards, the health endpoints that we were actually concerned with, without revealing the exact chemical. And that's something they can do in that format, and that, we hope, will kind of bridge that gap of starting the conversation without having to reveal trade secrets, which in this industry is a very closely held card to play. Healthy Building Network, along with the Health Product Declaration Collaborative, who is the organization now leading that effort, continues to lead an effort to not only standardize the data, but also how to figure out how to standardize how it is consumed. So really working, and I believe this event is really one of the kickoffs of this too, really working with the people who will be using this data to standardize how it is presented, how it is consumed, so people can build other applications on top of this data and start to solve problems we may not have even identified yet, and start to address that, what comes beyond the red list. And that is our hope, that by driving this forward, that these systems are underway. As far as the campaign end, we think that with Lead 4's materials credits around transparency and optimization avoidance, that we also are starting to see that leverage begin. And that campaign begin where manufacturers have something they can drive down the supply chain and start to improve the way data is reported, the amount of data that's reported, and the overall, to be frank, enthusiasm for using this data in-house to create better products. Because if all we're doing as A&D professionals is avoiding products, we're going to have some pretty standardized, not very interesting buildings. What we need to do is to work together with the manufacturers to create better products going forward. So our hope at the Healthy Building Network is that in this room today, the next piece of my earlier question of, so where do we start, begins to take shape. Because it is the architects and the people teaching architects who must use these systems and these tools and this data to lead the campaign for better materials if we are truly to change the marketplace for building materials. This opportunity is a big one. And now, to prove that I am a data geek and am qualified to speak to things like data challenges, I'll close with a quote from one of my favorite philosophers, Yoda from Star Wars. And that is, do or do not, there is no try. So I really want to just encourage us to do this and get this done and get this started and make the most of this opportunity. And so with that, thanks for listening and look forward to talking to you all this morning.
Good morning, everyone. I'm going to be talking to you about two topics, so materials education and innovation. So just to give you a bit of background about myself, as Chris said in my introductions, I'm a materials scientist, and I just joined the US Green Building Council about 8 months ago. So I still have a relatively fresh perspective on this building conversation, and I'm really have been examining some of these issues from the lens of a materials researcher, and I also spent a little bit of time in government policy as well. So I'm kind of coming at this from that angle. And what I wanted to talk to you about today, three things actually. Before I get to these two questions, I'm going to touch a little bit on just what these new credits are in the LEED rating system that have kind of accelerated this conversation. And then I want to talk about two issues. Firstly, whether or not the education that scientists, primarily materials scientists, are getting today actually aligns with what LEED is expecting out of materials and products. And then secondly, what the challenges are to creating new materials and new products that actually meet the requirements that LEED has set forward and that really give us a healthier lifestyle. So wanted to first put this slide up. I'm going to contrast in a minute what materials scientists think of when they think of sustainability. So the US Green Building Council, as many of you will know, takes a very broad approach to sustainability. Even though a lot of people identify LEED with energy and the environment, we're much more broad than that. And when we're looking about community quality of life, green economy, water resources, and of course the thing we're all here to talk about today, human health. So what is USGBC doing regarding materials and health? So the thing we're primarily discussing today is some updates to the category of credits called materials and resources. And in the new version, LEED v4, which we just announced at Green Build in November, we're really taking a more overall life cycle approach to the category. So there's some credits in there addressing whole building life cycle assessment, and then a number of credits that are emphasizing transparency and outcomes, which of course, transparency and outcomes regarding human health is one of those aspects. And when we talk about the life cycle approach to this category, we're really being incredibly inclusive, starting from extraction of raw materials to the manufacturing, to the worker who is actually constructing the building, to the user who is in the building, to deconstruction of the building, demolition, waste management, all of these things. And when we talk about disclosure, we're talking about, as Larry was just discussing, actually knowing what is in our products, having a comprehensive list. And when we talk about optimization, we're talking about rewarding through our credit products that have actually gone through the process of trying to be healthier. They do not contain any toxic ingredients. So we have a couple aspects to our materials ingredient credits. So the first one is a credit for reporting. And this is basically saying that we would like for architects to be specifying a certain number of products that at least have disclosed what's in their product, a list of ingredients. And it's not saying they're good ingredients or they're bad ingredients, just that we know what's there. So with regards to that, we accept a variety of ways of reporting this. We can take a manufacturer's own inventory. One can use a health product declaration. That's the format that Larry was just talking about, this kind of uniform format, standardized format for reporting materials ingredients. Through the cradle-to-cradle assessment process, there is also an ingredient list that is created through that. And then we leave room for other possible programs we might approve in the future. So when we talk about this inventory data requirement, we're looking for this comprehensive list that includes the chemical's name, this chemical abstract service registry number that Larry was talking about, how much of these ingredients, are there any residuals, and is this a self-declaration or third-party assessed? And just to give you, a look, if you haven't seen a health product declaration before, this is an example of one. So we have this, list along the left-hand side of the different ingredients, and of course we even, as Larry said, there's an allowance for not disclosing the ingredient, but instead simply disclosing its health hazards, if you'd like that to, remain intellectually protected. And then we have the CAS identification number, the amount of the chemical, the health hazard warnings, and the role of that particular ingredient in the product. So the second part of the credit is then towards optimization. So this is where we say we'd like you to specify products that don't contain toxic ingredients. And so USGBC doesn't try to set its own standards for what it believes a toxic chemical is or a product containing toxic ingredients, but we rather reference some outside organizations that have set standards for this. So in the case of this option 2 for the credit, we have we reference green screen, cradle-to-cradle certifications, and reach optimization, which is, of course, more prevalent in Europe. And then again, we leave room for other programs that might come up along the way. Okay, so with all of this, often architects kind of look at all this information and go, oh my gosh, I need to know a lot of chemistry to begin to understand this, to specify healthy products, like what can I do about this? And well, here's the thought. Should I hire a material scientist as a consultant? Material scientists ought to know more about this. They're materials experts, right? So I just spent the end of last week at a conference for material science educators. So a lot of my thoughts during this talk have been colored by that experience last week. And I will also say the focus of this conference was not just materials education, but materials education as it relates to sustainability. So this is a list of words that I compiled that I heard often spoken during this conference about how material scientists are teaching sustainability. So there's a lot of words on this list. We have, words about life cycle assessment, being energy efficient, recyclability, even self-healing materials that can kind of, repair a crack on their own or something, environmentally friendly. We talk about climate change. We're even starting as material scientists to talk about concern for critical minerals that we might not be able to get access to in the future for various reasons. But the one thing that you don't see on this list that is relevant to the conversation we're having today is any word regarding health. Material scientists don't often talk about health when it comes to materials. So if we look at how material scientists think about sustainability in terms of a definition, this is one that's just standardly reported throughout the sustainability community, which is, of course, this Brundtland Commission report that essentially says that we need to meet the needs of the present without compromising the ability of future generations to meet their own needs. Now, if we look at a definition that's more tailored towards materials scientists, this is a definition out of the Materials Research Society's primary magazine, the primary journal, the MRS Bulletin. So this is a special issue that they had back in April of 2012 on materials for sustainable development. This is a more comprehensive definition. So we talk about environmental stewardship, materials management, green manufacturing, renewable and clean technologies, air and water management, etc. But again, you do not see the word health. Materials scientists don't really associate health with sustainability. So how do materials scientists think about material selection and design? So I would say the most important things are function. Does it have the mechanical property I need, the optical property? Is it magnetic? Does it have the electrical property that I need? And performance, is it going to last a long time? Is it robust? Does it have that strength and toughness that I need? Cost will be a concern, probably more to industry than to researchers. Scientists are starting to often think in terms of sustainability with an energy footprint of materials, resource availability. One thing that I did hear a little bit of in this conference last week was people talking about managing electronic waste. So there's a little bit talk of the environment and how waste might impact the environment, but not so directly how might waste and how might toxic things impact people themselves while they're using the product. And I kind of feel like what's happening here now, of course, this is not just a material science question. Chemists design materials and products. Chemical engineers are part of this equation as well. And of course, we have the toxicologists that are actually doing the research to try to determine if a certain chemical or material might pose a health hazard or risk. But I feel like any of the information that the toxicologists are producing kind of falls into this hole. It should be a nice overlapping intersection of these fields, and toxicology should hopefully make its way to all of these fields collectively. But I feel like a lot of times, it might be a little bit different for the chemistry and chemical engineering community, but even in these communities, health is not as large a part of the conversation as it should be. So I feel like while toxicology should be informing these conversations, it often does not as much as it should. Okay, and this is the question that I posed last week, is essentially like, why do we seem to significantly prioritize saving the environment rather than saving ourselves? Because it's difficult for us to then save the environment if we're all sick and dying, so. Okay, so you may then be asking yourself, are there a lot of products out there that are optimized to contain these non-toxic ingredients? Can I go and buy some stuff that's gonna meet these new LEED credits? So the answer is not so much yet. They may in fact be optimized, but we simply don't have a list of their ingredients, or maybe they contain toxic chemicals. A lot of times we don't know. So there are not a lot of products out there with these certifications now that assure us that they are non-toxic. So you might then say, when can I expect more products to be out there that are disclosing all this information that I can be sure are safe? So I'd say the answer is it's complicated. I think a lot of architects are hopeful that within a year or two, we will see a lot of products out there that meet these requirements. And in the cases that it's a product that simply hasn't disclosed its ingredients, and maybe they do a little bit of research and they discover, oh, we're actually good to go, that'll be something you'll find out quicker. But if in fact it does contain a harmful ingredient, this is tough. And substitutions and product redesigns can be somewhat simple, or they can be much, much more difficult. So a relatively simple example would be, for instance, if you're looking at an office chair. So polyurethane foam contains flame retardant chemicals, and a lot of these chemicals have very, very questionable health impacts. And so one idea would be to simply redesign your chair so that you don't have a polyurethane foam cushion and you have a mesh instead. I mean, even this is a difficult challenge for engineers at a company. You want to be sure that your product is going to perform to the standards of your company, because it will reflect poorly on your company if it doesn't. So this still takes a long time to redesign the chair and make sure it's going to meet those performance requirements, but it doesn't necessarily involve a redesign of the chemistry and the true materials science behind that product. So a slightly more difficult example would be a plastic bottle. Plastic bottles, up until recently, contained BPA, but now we have these wonderful BPA-free bottles. We should feel really, really confident that they're safe for us because they are BPA-free. And now BPA has been often replaced with something called BPS, which is bisphenol S. Now, if you saw the recent news headlines, as it turns out, perhaps BPA-free plastic is less safe than those that contain BPA. So this is what we call a regrettable substitution, in which perhaps science has not advanced to the point where we've actually tested every single chemical we may be replacing one with. And so this is why I'd say that the red list approach, Larry said the red list is where we are now, but we probably need to step beyond that, because we have a list and it says BPA is bad, so we take out the BPA. Well, BPS wasn't on that list, so we think we're okay, but maybe we're not. So the drawback is that really thinking through getting all this toxicological data, making sure we've designed a product safely, that it meets all these performance standards, it takes a lot of time. And when I say a lot of time, most people in the industry would agree that completely making a new product, bringing it to market, everything from the research through to it becoming a product on someone's shelves can take 10 to 20 years. This is a long time. So, the factors that affect the speed of this are money, primarily money. If you ask anyone in the industry, what's the #1 thing preventing you from taking this toxic chemical out of your product, they say money. Now, progression of science, in some cases, we just have not tested all of the chemicals yet. And then in terms of performance standards for a company, will it perform up to, in some cases there might be a code that a certain product has to meet. Will it meet the quality standards of the organization? I was at a conference a couple weeks ago where the sustainability director for Lego spoke, and he said, Lego has been examining whether or not they can switch out some materials, some chemicals in their Legos to make them more safe. And he said, one of the things that Lego truly values is that generations of people will pass on their Lego sets. A father will pass on his Lego set to his daughter, and so on and so on. And he said, the Legos that were produced 50 years ago need to look exactly like the Legos produced today, need to look exactly like the ones produced 50 years in the future. And when you're switching out chemicals, this takes a long time to get to that point where you can really feel certain it's going to meet the quality standards of your organization. Okay, so that all sounds really depressing. So I wanted to at least end on a slightly happy note that you may ask yourselves as architects, is there anything I can do to speed things along? So I would say the more that you demand ingredient lists from manufacturers, the more that you preferentially select materials that have these ingredient lists and that are optimized, this sends a signal to the industry that says, this is important, I'm only going to buy the things that you optimize. And I think that message then filters back down into the materials education community. So as manufacturers say, this is a priority to us, They want to hire workers that, you know, have thought about materials and health. So they start telling the materials science and the chemistry departments at universities, like, please train your people in this because we want to hire people that come into our organization at least having thought about these things somewhat. So I think this will take time, but I think the more and more that you demand and place an importance in the industry's mind about this topic, the more it will accelerate and start to actually happen. All right, thanks.
All right, that was not so depressing. All right, so I just have a couple of quick things before we go for break. So we're gonna have a break, but I wanted to give you a sense of the arc of the day from this point forward. So we're gonna come back and we're gonna hear from two leading practitioners about how this hits the ground on the street and what folks are asking for and where the profession is going. Then we're gonna come back and we're gonna talk about how it affects the kind of education for the next generation of architects. And so just a couple of thoughts just to seed your coffee break. So there are a bunch of interesting people in here, so you should definitely shoehorn almost anybody you bump into if you don't know them is likely to be very interesting in this room. But a couple of things just to reinforce. I mean, you know, what you heard in terms of teeing up how challenging this is. One, we started by hearing about the literal alphabet soup of regulatory regime. I mean, and Tracy helped us navigate the alphabet soup, but boy, that's a lot of regulation to understand. And Larry helped us understand that need to basically first start by translating literally dozens of lists out there to have something you can do today, and Ashley helped us understand why just translating lists is probably not going to get us all the way to the finish line. And I mean, two things that jump out at me. I mean, I'm not sure it was said overtly, but there's also this assumption that, you know, when we as professionals, we may specify this material or this material, and we presume if that material was really hazardous, the government would protect us, right? I mean, there's a presumption that if I'm allowed to go down to Home Depot and buy this, it is ultimately safe and tested. But the reality is the testing is us. We are the lab rats in this experiment, right? We are in our version of a FEMA trailer, figuring that out over some length of time. And so just that challenge to think in your head about, have we created the regime where, in Ashley's sense, why are we so reluctant to protect ourselves, and why are we protecting other stuff? And just as some challenging thought. So